and I will hand it over to you.
Thank you.
Thanks.
So the great thing about a startup, which they never really tell you, is you can forget about sleeping and planning things, in an orderly way. So one of the things I see when I mix is the headline of what I was actually going to talk about. So I can talk about anything, but I'm not going to talk about bitcoins and blockchain because I think that the two previous people there have done a great job. I don't want to also plug Pycom, this is not what we're doing here, but what I'm going to do is probably talk about the difficulties that people face when they try and connect devices to the Internet of Things. So we've heard applications here of IOT, what happens, and things that are good about IoT, and then you've got all the bad things. And one of the reasons why we set up Pycom, it was 14 months ago, and in 14 months I think, hopefully you'll agree, we've done quite a bit, was this belief that there was a better way out there of connecting devices. And so we wanted to connect devices in a way which wasn't being done today. And there was also this need to help the developer community to build these applications for IoT which actually are robust and future-proof and so on. So in the first 6 months of trading, we secured 4,500 customers, developers, and so on, and that continues to grow. And so we're cultivating this community. So what I want to talk about is what are we trying to solve and why it's important for IoT. So as you do, you come up with formulas which you try and convince yourself. So we believe we can save 12-point-something billion hours of development time a year. And how did we come up with this crazy number? And believe you me, we were shocked when we thought about it. But typically, an IoT application today takes about 7 to 8 months from start to get in a prototype. Then you've got to get to stage 2, which is after you've got a bit of funding and stuff, and you go and productionize your idea. And then you're into 18 months time as a minimum, right? But let's forget about the manufacturing. Just the development and prototyping, you're looking at 7 to 8 months. And we thought, how if we could cut that down to a few weeks? Okay. And so one of the other things that really frustrated us, and there's 3 co-founders with the same passion, is that when you look at the IoT world, and you look at companies that say we're going to help developers really get IoT products to market, they all come up with a middleware platform. And you think, gosh, there's 550 of those platforms in the world. Do we really need one more? What is that going to do? And our thinking is, actually, if you want to resolve this problem, you've got to start at the root cause of the problem, and that's the device itself. So that's what Pycom seeks to do, and we believe that from 7 months we can cut that down to 2 weeks. And we've been launching applications with AWS, which I can talk about a bit later. So there's a huge untapped potential in IoT. Okay, and these are stats out there. So Gartner, whoever reads Gartner reports and has been part of the Magic Quadrant or whatever. I don't know if you paid a lot to do that. But the fact is that market research suggests that by 2020 there will be about 25 billion devices connected to part of this Internet of Things. And yet today, as of 2015, it was short of 5 billion. Now, I've been spending many years in new technologies, 28 years more than I care to think about. And I spent the last 3-4 years in what's called the M2M cellular business. And you can do pretty quickly calculations, know what these mobile network operators are putting on their networks. And if you're Vodafone, I think at one point it was 500,000 new devices per month. Now, there's not many Vodafone in the world, so you can think it's about 4 or 5, you do the calculation. And the maximum you're going to come up with is about 1 billion devices. We came up with that figure within 5 minutes. Gartner came up with that after a year. And so you think if there's 25 billion devices and 1 billion is on cellular, where are the other devices going to come? So, of course, you've got things like Wi-Fi, so connecting the machine to a Wi-Fi network, that counts. And that's where you've got your 5 billion. So you're thinking, how do I get from 5 billion to 20/25 billion, and let alone the 200 billion, which is then city nodes and stuff that connected into that. And the fact is there's got to be a game changer that takes place in this industry, because if not, it's not going to be 20 billion. So that's one of the other things about Pycom. So we serve 3 communities. We serve the maker industry, we serve the professional developer industry, and we also are passionate about education, because actually education is the whole thing that we stems through. So we are going to sponsor a lot more educational projects. We're fortunate enough to have a great team of investors who are philanthropists, people who made significant money in previous lives and want to plow back. So Pycom is about that. So we're helping developers through the education process, and then we also are trying to bridge this gap between the hobbyist developer and the enterprise developers, because actually what you find is the ideas are with the makers. And so, you know, today I was hearing about your application, which is fantastic, about flood level, you know, and flood risk, and how do you monitor, and how do you make sure you send alerts if these riverbanks are bursting at levels and so on. And so what you find is a lot of developers need support, because they're not the Siemens of this world, they're not the Bosch of this world, and therefore not many people want to give these guys a ton of support. So Pycom we try and do that. Okay, I've talked about some of the problems. I'm just going to look at one point, which is edge of network, and we mentioned it, or Simon did earlier on, when we were talking about the Bitcoin and so on. So the old topography of Internet of Things is dumb sensors on the edge of network, feeding back data to a centralized point, processing that data, making a decision, and then taking an action accordingly. And the fact is, if you look today at a lot of these types of applications, you're probably talking of 99 to 98% of data gets beamed, and only 1 to 2% is actually data they use to make a decision. So somebody's paying for that communications. There's a huge wastage, and again, we talk about business models, which today still don't exist in the Internet of Things, and really you've got to get to a zero cost type of business to be able to really exploit the Internet of Things. And so if you've got 98% wastage, you can see how much this is costing the whole thing for implementation. So edge of network devices need a different breed of element brought to them. So one of them is battery. Now, you think it's silly, but the fact is a lot of devices in the end-to-end world are powered by mains. And so, you know, if you talk about, again, the hobbyists of this world, they tend to use a Raspberry Pi, which is a great device, but the problem is you need mains. Or you then scale with an Arduino-based something, and then you find that you've got the problem. So edge of network is something that we are focusing on because it needs battery. It needs an element of intelligence that can, so you're talking about artificial intelligence, being able to make decisions on the spot without necessarily feeding that input back to the central server, unless there's an exception. You know, something's happened, I need to trigger a message back to base. So we are only focused with this element because this is where we believe the 20 billion devices are going to come to life. So, a bit of humour. I really don't know if you can see that, but this one here, can I interest you in a firewall for your toaster? Well, the fact is, last week, as we mentioned a few minutes ago, you know, a DDoS attack on a server that led to Twitter being brought down, which ironically I was trying to post this bloody photo on Twitter and it wouldn't let me, and now I realised what was happening. My toaster was frying the system. But the fact is, it's a very silly thing. And so if you don't build an intelligent IT device with unique usernames and password, and someone knows that all these devices are made somewhere in China with the de facto username and password, they're going to hack your system, they're going to redirect that traffic, and you're going to become one of the culprits. So that's one of the things. All right, the good. We love this. I don't know if you ever go on Kickstarter, but This is a good innovation for us. I don't know if it'll ever take place. It's a photovoltaic panel which they've embedded into resin, stores the energy of the light, puts it into a battery, and then in the winter it heats up, so it defreezes. At night it lights up so you can see stuff. And so, this for us, we think this is a cool application. You might think it's rubbish, which is fine. And then the back, a connected dog computer. Yeah, we did see that. A connected front door that all of a sudden crashes and you can't get into your house, but you can report the bug. So hopefully they can fix it pretty quickly. And then the final thing is your Hoover uploading 25 megabytes of data. And then you can imagine what that's doing. So these are things that are out there in one form or another. And this one is, I can't actually show this because, can we or not? I mean, it's like, don't worry about it. I can describe what's going on, but you've actually got a Roomba trying to get past the chair, and it looks like it's being, whatever the word is, fornicating or whatever. And so it says to his mum, how are Roombas made? These things.
Maybe it's using a smart contract, charging by the
Exactly. So these are things, but here obviously the sensor can't pick up, there's something in between. All right. So Pycom, as I said, the idea was born here in a coffee shop, and not one like that. It was at Schiphol Airport, not in Amsterdam. And myself, Daniel, who's CTO, and Bettina, who's COO, we had this passion and vision about the IT world and how we could make a difference. So today, Pycom, we secured a seed round of €1.5 million without having to give all our crown jewels away, so we're absolutely delighted about that. We have 14 people working in the company, half are developers based in Eindhoven, and Roberto is one of these developers. We did manage to get one Dutch guy. I mean, we were struggling. People were saying you're a Dutch company, but you don't know the Dutch development.
Is there so entrepreneurial though? They're all doing their own stuff.
Well, exactly. Right. So anyway, we took Roberto out of Venezuela, brought him over, and so. Oh, there you go. There's another one. So Daniel also. So we have Venezuelans, we've got Latvian, we have got Dutch, we've got Greek. I think that's it.
Russian.
Sorry? Russian, yeah.
Brits.
Sorry?
Brits.
Brexit.
Well, the Brits are in the UK. Yeah. So we have the development centre in Eindhoven, and then all the UK legal sales, marketing in the UK, and then we've also opened up offices in France. So the other thing we did when we went to seed fund is actually chose intelligent people. And I'm just saying that because I think some of you guys have got some ideas you're going to be looking to prototype. But we wanted a partner, investor that could also manufacture the product. So Intech, who manufactures all of our products, has a stake in Pycom. They were set up in the 90s. They're Hong Kong with manufacturing in Shenzhen. 4,500 people, 500 million devices they make each month. And the benefit for us is we get priority in that entire production phase, and so we can bring in a product from idea to manufacture within 60 days. And that is the timelines we're working on. I can tell you there's many hours of work that goes into that. And then obviously we add all the firmware and stuff ourselves back in Eindhoven. We also have investment from one of our chip manufacturers, Espressive, and so it's not just about going for investment, it's also about going for investment with a value provider. So that would be my recommendation to anybody who's looking to do something. Okay, typical approach to product development is they say, okay, what do you want, quick, cheap, or high quality? And they say you can only choose two. And you think, no, I want the three. And that's what we are trying to do. We're trying to make it as highest quality as possible at the right price and incredibly short timelines. And so On the October the 10th, we released our first module, which the University of Edinburgh has been organising a hackathon for earlier, which was great to see the students out there and hacking away, and I think some of you saw earlier in the sessions. But that's just one module. So, for us, we believe in multi-network. And so I don't know how many people are involved really in the Internet of Things, but the typical way you would connect a device, as I mentioned initially, is using cellular. And so cellular is good because it's high bandwidth, it's high speed, 4G. The downside is expensive because you've got Qualcomm license fees to pay, which make 4G so prohibitively expensive for a lot of IoT devices. And there's a huge drain on battery. So great applications if you're powered into the mains and you've got a screen and you're doing advertising, then you're going to have 4G. But the fact is, a lot of these devices, which are 20 billion devices in the market, they're never going to live and need those prices or speed. So everything we do is powered off a battery, and we offer multi-network. So the Wi-Fi, which is the first, how many people have bought a low pi, or I understand there's a few, yeah, there's a couple here, 3, okay. Right. So this is the first one, Wi-Fi and Bluetooth, so you can do multi-network, basically many home or business applications. The Wi-Fi, we now have 1 kilometer range on Wi-Fi, so that opens up applications in the city. And again, the benefit is Wi-Fi can be kind of free. The low pi, we start adding the LoRa chip. So I'm not sure how many people know what LoRa is. LP1, low power wide area network. And so this is a different style of transmission versus a traditional cellular in the sense that it's what we call a high bandwidth of radio spectrum, and it can travel a lot further than cellular. And it also has different benefits versus cellular, which means it can penetrate into concrete. And so if you've got a lot of your devices which are in basements, like some vending machines deep into buildings, or lifts where you need to press a button and say, I'm stuck, you need to get through quite a thick barrier of stuff to get to that device. So LoRa has been a technology that really has come to life, I'd say, in early 2015, late 2014. Something that was invented in the late 80s in France. Semtech took over the technology, they make it available on the chip, we put it on there. The next one, so the benefit I should say of LoRa is, just like the university here, you can get a gateway and you can put that in your building and you can become what's called a service provider. And so you can open up your gateway to other people who have built devices using the LoRa technology. And then you can decide if you want to charge or not. So you'll see in a lot of these communities, like the Things Network in the Netherlands, or just private cities coming to life with these technologies. A big community play, a big developer play, and so there's big benefits there because you can actually get technology for free. The SciPi uses a technology called Sigfox, so there we substitute the LoRa with what we call Sigfox. And Sigfox is kind of the same as LoRa, except that it's an ultra narrowband radio spectrum, and so it's supposed to travel even further, but a lot more directional than LoRa. And so that rollout is being done as a network, as if you're seeing so Sigfox roll out what they call Sigfox network operators. They control the entire network and it's closed. So against the LoRa, which is open, Sigfox is closed, but the benefit then is you get SLAs. So if your device is business critical, you're going to need an SLA. If you want consistency in the upstream of data or the availability of the network, you're going to pay a bit more. And so that's where you'll see in Sigfox for businesses that say, mine is business critical, I need an SLA, I need it up 24/7, versus the community play, which could be connected to this wall, and I've just unconnected it to do the Hoover, and then I'm back in my DDoS mode. All right, the next thing we'll bring out is cellular, because cellular has got a new competitor to Sigfox LoRa. So what you see is the network operators, so the Vodafones, the Telefonicas of this world, the AT&Ts and Verizons, who for years have had end-to-end devices on their networks, and for years have had a real issue with having their devices on their network. And the reason they have an issue is because, unlike you and me that have a mobile phone, and we have this usage, and if you've ever got a daughter like mine, then you always pay more money to the operators because she's on YouTube every day and off the Wi-Fi range. And so they love that because humans are very unpredictable and they bring them a lot of money. A device typically sends very little data, and so they never can make that much money out of the device other than what you contracted for. And yet you're using the towers, and then you cause network storms if you've got all your iPads connecting to the network at the same time. And the spike on what's called a HLR in the network environment, you fry the systems. And so some of the networks have gone down, and if you ever heard of Telenor up in Scandinavia, they had their network off for 2 days because of the networks, what's called a storm of cellular connectivity happening at the same time. And then and because then each device saying, hey, I want to connect, they re-authenticate. And so each device then sends 100 re-authentication. So these network operators are keen to take this traffic off their normal network operators, and they've brought up this technology, or they're pushing the technology called LTE-M. And so LTE-M will be a competitor to LoRa and Sigfox. There's 2 types. It's dependent on the data speed. So at Pycom, our next device that we'll launch and make available in February 2017, I've got the first prototype here, has got LoRa, Sigfox, Wi-Fi, Bluetooth on this side, and here you can see the nano SIM card, and here the cellular device. And so what we're trying to do at Pycom is to push the boundary and make all of these networks available on low-cost devices. Pycom, so we do Python. I don't know how many people program in Python, so there you go. So MicroPython is a version of Python, and that's what powers let's say, it's the high-level language we use for people to program the devices. It's open source. We build the libraries, and now we're going to have all of our thousands of developers being able to contribute to the source code and do things that you would expect. All right, I just probably want to, I don't want to, yes, that's probably how you feel. Okay, let me just show this one. I was asked earlier, could you just give an overview of the 3 technologies? And so here they are, sitting side by side. So if any of you are looking to our devices and you need connectivity, we've talked about LoRa, the TTN, so things network and personal. There you make it free. There's low cost because it's shared by the community. You have LoRa commercial. In the previous session, we talked about some of the operators who are bringing out LoRa commercial. So there you're starting to get SLAs, but obviously you have to pay. And so then that's a consideration you're going to have to think about. Sigfox is a closed network, although it's an open source chip. And there again, you start getting SLAs, and cost can be medium, a bit like a LoRa commercial network. And there I've spoken about LTE-M narrowband IoT, which is the new cellular. So that's it. Thank you very much for your time, and obviously, questions later.